12 syllabus has 16 chapters.
Now, if you classify them into different branches of chemistry,
Then, if you go for physical chemistry, which is also known as general chemistry, has
5 chapters.
this is solid state, then solutions, electrochemistry, chemical, kinetics, and surface.
These are the 5 chapters you have.
Then we go for inorganic chemistry.
Inorganic chemistry, there are 4 chapters are there.
So I'll continue with this number. Huh? So it is called general methods of isolation of elements.
Means, how do you go for the extraction of different elements from their compounds which is found in the nature?
Then comes P block elements. In class
11 whom I have taught, because of the we have started so late, because of that I could not discuss with the P block elements.
So P block elements in class 12,
11 you are supposed to study group 13 and group 14. In class 12 you will study group 15, 16, 17 and 18.
that is group 15 to 18. Then D and F block elements. Then you have coordination chemistry.
See, though it is there in your book, but I'll suggest that you please write down. Once you write, then you are able to remember. Others will be in the book only. Please write. Once you finish, please tell me, huh? Otherwise, from the other end, is very difficult to know. Any type of inconveniences or problem that you have, immediately tell.
So what is the word in number 6? General methods of?
General method of isolation of elements.
Thank you, sir.
Organic chemistry. Haloalkanes and haloarenes. Good. Alcohols, phenols, and ethers. Aldehydes, ketones, and carboxylic acids. Amines and diazonium salts. Biomolecules. Polymers. Polymers. Then you have chemistry in everyday life. So you should know, in your book, they have given all the chapters, but they did not classify. So at the very beginning, you should know which chapter belongs to which branch of chemistry.
So what did you write in amines?
Hello?
So
Yes,
what did you write? So what did you write in amines and
amines and diazonium salts, DIAZONIUM. Diazonium salts. Done?
Yes, sir.
That, sir.
Okay. So these are the chapters that we are going to do. Mind it, 16 chapter means the syllabus is large. So you must have patience. As I told you, I shall try to give as much time as possible. I will not go in a hurry. By teaching so many years, I have a teaching experience of around 40 years. Okay. And I had been teaching these 11, 12 students in my house, I think more than around 16 years. So I know how the things are being taken in your school. I'm not blaming your school. I'm neither as a teacher, I don't want to criticize as a teacher, because most of the time it is being taught in a hurry. I shall try to give maximum time for you so that you should get exposed to these branches. Please do not feel that chemistry is a difficult subject. It is one of the easiest subjects of science. And in this syllabus, present syllabus, you have mathematical derivations are very, very few. I know most of the many students of the CBSE schools have dropped out mathematics. I do not know whether it's a good decision or bad decision for you. It is up to your convenience. But this much I can tell you. Science, the physical chemistry. This year only in class 11, I was taking organic, but of course I have taken the organic in detail, because organic in 9 and 10 also your knowledge. Solid state. So before you start with the solid state, let us recall the states of matter. States of matter that you have studied in class 11. And there we have found that it is being told to us that there are 3 states of matter out there. But actually, matter can be classified into 5 categories. These are 3 we know right from our childhood. This is solid, liquid, gas. And the 4th state of matter is called plasma state. And the 5th state of matter is called Bose-Einstein condensed state. So this is for your information. But anyway, let us restrict our discussion to solid, liquid, and gas. So solid, liquid. This one we have studied in class 11. Different laws of the gas and everything we studied. This liquid state in class 11 somehow was not being taken due to pandemic. So I feel very sorry for that. So now this one we will study as being prescribed in your book. So I have a limitation of going beyond that one. So I'll try to restrict myself to the syllabus which is given in your book. Now, we know this existence of the matter in different states. Okay? It is not a divine process. There's no divine rule is there. That some of them will born as a gas and shall remain as a gas. Some of them has come to this universe in the form of liquid and it will remain like liquid. And others will be remaining in the form of solid. No, it is not like this. So we find the existence of 3 states of matter
depends on the intermolecular forces of attraction, which is also known as van der Waals forces. So substances in which you find the forces of attraction is very high. So in that case, they come very close to each other, almost touching each other. Okay. Like this. So they exist as. So that is, we can say here, highest intermolecular forces of attraction. Those in which the forces of attraction is minimum or negligible, they exist in the form of this. Okay. Now in between, you'll find, in that case, you'll find these substances have little less intermolecular force of attraction. That is, little less internal force of attraction than solid. Therefore, liquid. In solid substances, you cannot put your hand inside because they are very close to each other. Okay. Solids cannot move by themselves. Why they cannot move? Because there is no space between the or among the particles to undergo displacement. Solid of its own never undergo any displacement. They cannot move by themselves. See, in case of liquid, spaces are there. So in this case, some molecules can undergo displacement. They can move further. So if you spill water on the table, you'll find the water move. It's not that water is falling down. Because when it's a question of falling down, gravitational pull is there. That is different. Even if you drop a solid object, also will fall down because of gravitational pull. But of your own, they cannot pull. But if you pour some liquid in a container or on the table, you'll find the water will move. Why? Because the pressure system. See, because of that, you can jump in a swimming pool. When you jump in a swimming pool, this molecule will immediately push backward, make some space so that you can go down. But you cannot jump. If you jump in a frozen lake, you will not go down. In fact, you will get hurt. In case of gaseous substances, distances are so large that anything can move through them. Because of that, we can walk on the road. We know air is there. Big vehicles can move. Elephants can move because that they cannot put any obstruction to us. But suppose if you compress them, suppose you compress, the pressure is there, then this also can come to this level, or even this can be like this. Because of this, the gas can be liquefied and it can be solidified. All the gaseous substances which is available in this universe can be liquefied or even solidified. Okay. So now we'll go to solids. Did you take your book? Open this chapter solid state. Open it. Whenever you sit with the book. It may happen, suppose I may miss out because I'm not teaching you from your textbook. Textbook I have. Okay. Textbook I have, but I have not opened it. I'm just telling from my heart. If you find that some portion I did not take, immediately tell me, sir, you did not. How the solid formation has taken place, now we know that particles, they have tremendous force of attraction. They have come very close to each other. And in that case, they almost stick or touch each other. Now, when they come, when they arrange themselves, it can be done in two ways. Even you also, suppose you want to arrange your table where you have kept the book. So in that case, if you have enough time, then you keep the copy in one place, then you keep the books in one place, then books, whatever the books you have also, they have different sizes. Some are large, some are small. In copies also that you buy for the market, different copies have different sizes. So you keep it like this. So it is a very systematic arrangement. So your table looks very neat and clean. But if your time is very less, you want to hurry up for your school, in that case, all of them you pile up and keep it in one place. You may find that within copies your books may be there, or within books your copies also may be there. And the books and the copies of different sizes are different. You'll find they are not placed in different places. They are all jumbled up or mixed up. Similarly, in solids also, the particles. When see in solid state, I have only most of the time I'm going to use the word particles because it can be atom, it can be molecule, or it can be an ion. Okay. So suppose you have arranged them very systematic. I'm intentionally keep some space for it. They're touching each other. Assume I'm keeping it like this because of that.
So this is the very systematic arrangement. You find between all of them, you have the almost same gap is there. Okay, so when you arrange them in this way, and as because solids are three-dimensional, so in that case, what is going to happen? After final arrangement, you will find they have taken a shape. They have taken a fixed geometric shape. It can be like this. It can be like this. I'm very poor in drawing, and please don't laugh. Okay. Like this. So they were the finer shape. So what you call them? We call them crystals. That is a regular and systematic arrangement of the particles give a fixed geometric shape to the solid substances, which you call them as crystals. So what should you call them? We call this one to be crystalline solids. Have you seen any crystalline solids? Hello. Tell me the name.
Sugar,
Yes. Then
sand.
Hmm?
Sugar.
I couldn't understand. Sugar, I understand. What is the second one you told me?
Salt.
Yes. Please remember, both sugar and salts looks like this. Almost looks like a cube. Okay. Now, how will you feel? Suppose someone is blindfolded you, or in darkness. How will you differentiate between sugar and the flour, or maida we say? How will you differentiate? In a dark room, how will you differentiate which is sugar? Because chemical substances we are not supposed to put in your mouth. So how will you differentiate?
By feeling it.
So what will be your feeling?
Flour will be soft and sugar or salt will be more hard.
Hard means, how do you know? That is, if you press it in between your finger, then you get hard. No? Is it not? Why do you get hard? Because of the sharp. See, these are the sharp pen. That is, what is a crystal? We can say that these are some geometrical shape bounded by plane surfaces. See, they are all smooth surfaces, plane surfaces meeting at a sharp end. So these are the sharp sides of the crystal. So moment you put your finger here and here, you'll find you'll get hard. So this is the way we can differentiate between a crystal. But suppose you take a small pebble, round in shape or maybe other in shape, if you press it, you will not get hard. You will not get hard because it doesn't have any sharp edge until and unless you don't break it. Clear? So this is one arrangement. Okay. So now see, this arrangement is same at the beginning and at the end of the molecule. So this type of arrangements we call it long range long range. Okay. Now what are the other one? You find, as I told you, you're in a hurry. It may be like this. See here. So it doesn't have any fixed shape. And moreover, the distances between them are also not same. So they do not have any fixed shape. So such type of solid substance are called amorphous. We call it as amorphous. Okay. Now this, see here. What is the meaning of morph? Morph means its outer look. This word morph you have used in biology. Whenever in biology, if you have to explain any species, first you write there how does it look like, and we call it to be morphology. It may be a botanical species or it may be a zoological species. Okay. So a kitten will look like a cat only. The cub of a tiger also look like a tiger. So they have a similar morphology. Moment we put this word letter A, means it is the opposite word of this. So amorphous means which does not have any fixed shape. So we call it amorphous solids. Clear? Amorphous solids you have seen in your house. What are those? Say it is your talcum powder. It is the face powder that you are using. It is very smooth and slippery. In your kitchen, you have seen amorphous substances in the form of what? You find it is in the form of atta or maida. So these are the, or suppose you have taken corn flour. So these are all amorphous substances. In these amorphous substances, you find these two, see here, they are almost equidistant from each other. These two are nearer. Again, they are equidistant from each other. So this order of arrangement is limited to certain places. Moment to move from that place, that the order differs. All right. So this one we call it short range order. So this I can give you an example. Suppose you went to see Independence Day celebration in the ground. Okay. So there you will find there are two types of people. One, the soldiers and security forces, they go for march past. And second, you have the crowd. See, crowd can stand and sit anywhere. So they do not have any fixed shape. But when you go for see the march past of these armed forces or security forces, they will find they have made a certain pattern. And in that case, you'll find each and every soldier or the school children who is taking part in the march past, they are equidistant from each other. So this is a long range order and this is a short range. So could I make it clear to you difference between short range order and long range order? Is it clear now?
Yes, sir.
The properties of these crystalline solids and amorphous solids. So you'll find in your book the differences are being given. Okay. So let see what you have found now. crystalline solids and amorphous solids. Okay. Now what do you find here? What is the order of arrangement? What is the order here? Extremely ordered arrangement. Or what we can say? Long, wait. Long range order. What will write now here? See, what will write down here? Arrangement, not. What we can say here? For range. Okay. Now let us come to the shape. Crystals of the same substance will have the same shape. Okay. Definite shape. If you see the sugar under your magnifying glass, because at home you cannot have microscope, you'll find all of them are having same shape. Definite shape. Now what will say? Not definite. Okay, to see this one, no problem. You go to here a river by the side of mountain, you'll find so many different shapes of stones are there. Hardly you'll find two stones are identical with each other. Why? Because they are amorphous. Those are not crystalline in shape. Third, melting point. You'll find in melting point, in case of crystalline solids, have sharp melting and here you'll find not sharp melting point. I'm going to explain to you why it is like this. First of all, we should know what is called melting. How do you know the substance have melted? That you can say that is very funny, right? From childhood we have seen, if there's a hailstorm is there, after some time you find it gets converted into water. If I take ice cube from the fridge, we find it's being converted to water. Then we say it has melted. If you put butter on hot rice, after some time you find the butter has disappeared because it has melted and it has flowed through the rice grains. Okay. Now, what is the meaning of melting? Melting is this conversion of solid into liquid. When do you say sharp melting? Suppose I have taken a small crystal of this shape, and if I take a big crystal of the same compound, assume that its melting point is 76 degrees Celsius. The small one also will get converted to liquid in one go. This also will be converted into liquid in one. Exactly at 76 degrees, you find entire substance get converted into liquid. That is called sharp melting point. Okay. Now, why it is so? See, in crystals, say, I told you the solid substance cannot move. Solid substance cannot move. Okay? But we have found that when the ice has become liquid water, immediately it starts flowing. When it will flow. This will flow only when you have created a large distance between them. See here. So it can displace, and it can displace. How to convert this into this? Say you are traveling in a crowded city bus. You know your destination, you have to get down. So if you mildly say and politely say to the crowd that, excuse me, they will not allow you to get down. They will not move from their places because they also have some inconvenience of standing that place. But you have to get down in the next stop. Otherwise, you may have to get down at the place where the bus will stop, last stop. So it is not possible. So to make your way, what you have to do? You have to push the nearby people. When you push the nearby people, then we created this much amount of gap. Okay? You require this much amount of gap. Why? Because it is a place that you are going to put your feet forward or backward. If you cannot put your feet backward or forward, you cannot move. So this much space is always required. So in a crowd, we create this much space by pushing, but these particles cannot push each other. Then they should be provided with the energy from outside. So when you supply heat, what will happen? That you let us come back to the thermodynamics. First, the substance will absorb heat and store it within them. That is called internal energy. When it will go to the saturation level of internal energy, then again we know from the first law of thermodynamics that in that case, rest amount of the heat will be converted into work. What type of work they can do? Yes, they also can do the work. What will be the work they will do? They undergo vibrations. Because there is extra amount of energy, they have to dissipate. Okay. Suddenly, suppose you get terribly disturbed by some external sources, to express our annoyance or anger, we shout. That is the way we do our work, or we push. Okay. So similarly, in that case, what will happen? They will undergo vibration. They push each other, and this much pressure will be created. See, in this case, the order of arrangement is regular. Each and every one has a fixed distance from each other. So they require a fixed amount of energy to create fixed gap. Everything is fixed, and that fixed amount of energy can be provided by a fixed amount of heat that comes recorded in the form of temperature. Because of that, you find that crystal has a sharp melting point, irrespective of their size. Okay. Now, when you go to an amorphous substance, you find these three of them are equidistant. Then you find these are very close. Then you will find this is further like this. So this is our amorphous substance. See, here you have to spend more energy, most amount of energy. Here you have to spend least energy with enough gap is there. Here you have to spend, say it is mid. What will happen when you heat it? Is this portion is going to melt fast. Suppose the melting point of this one is called 76 degrees. Here you will find it is going to melt at 72. Then this portion will melt. Then this portion is going to melt last. So melting point is 76, but you will find it starts from 72 and goes up to 76. So they do not have a sharp melting point. They have a long range of melting. So this is an indication the substance is amorphous. Substance is amorphous. See, ice crystals melt at 0 degrees Celsius. But if you take a piece of glass, go on heating it, you'll find glass does not melt like ice. It gradually melts. What is the indication? The glass is not a crystalline substance. Glass is an amorphous substance. Okay, but ice crystals, ice cubes are crystals. They will melt at 0 degrees Celsius. Okay, now we'll go for the type. In your book, I have taken this one from your book. It's called cleavage property. Cleavage. It is, I have taken a crystal and this one, I cut it with a knife. Say, my drawing is very bad. This is a knife that you have cut it in 2 pieces. Moment you cut it with 2 pieces, mind it clear, you got 2 new surfaces. This is the new surface and this is the new surface. Both the surfaces will be very, very smooth. Why it is like this? See, we have taken a crystal. You want to cut this one. See, I cannot cut it here. I cannot cut it here. Why? Because I cannot cut an atom. I cannot cut a molecule. I have to cut. My knife should go between this. See, all of them are equidistant from each other. So when you cut it, the new surface that you get will be very, very smooth. Very, very smooth. Acha, very, tell me, is very common thing in our kitchen. Why we cannot cut anything by a blunt knife? Why you cannot cut? Why you have to sharpen your knife? Be it vegetable or anything else.
Because of the area of the surface.
Huh? Yes.
Area of the surface.
See here. If the knife is sharp, it will go through it. But if knife is blunt, and if you can see under magnifying glass, you will find this is the edge of the knife. So it is going to touch both the atoms or the molecules. And because of that, it does not go inside. If you make it sharp, then it goes. So in a crystal, the cleavage property we say that if you cut a crystal, the new surface that you get or new plane that you obtain is very smooth. But So what do we write now here? Regular plane pattern. Okay. It is the new surfaces obtained are very smooth. So now if you go for amorphous solids, this will be irregular cut. That is the new surfaces obtained is not smooth. Say, take the example, you have taken a stone. You have broken it. What will you find? Sorry, my drawing is very bad. So if I have got it, this is the stone. This is a new surface. Why? Because the particles by which the stone is being made, they are not equidistant from each other. Because of that, the new surface that you got is rough. Okay, now see, crystals are, you cannot compress them. You cannot compress a sugar crystal, it will not be smaller. Okay, what will you write? Generally, incompressible, because the distance between them is fixed and they are touching each other. Can be compressed to some extent, because some gap is there. If you compress, the particle can go closer and the size may be little smaller. It's not that you can compress to a large extent, to small extent you can compress them. Now, so now I'm going to discuss a very important property. I'll write first, I'll write down. Anisotropic in isotropic. Let me draw the crystals. Okay. See, this is the particle. See, in the length, 7 particles are there. In the breadth, 4 particles are there. In the height,
3 particles are. Okay. So this is very transparent crystal. I allow the light to go through this. Light will come out, but it will take some time to pass through because path is long. If it is like this, it will immediately come out because only 3 particles are there. And if I send breadthwise, it is going to take little more time than the height. With this, what we do? We try to find out is the refractive index. With the refractive index, you have already, I don't know, in physics practical, you could do it. You can find out the refractive index of a glass slab. Or you can find out the refractive index of any gem. Most of the gems are crystalline in nature. Okay. So in that case, the dazzling of light, what it takes place because of that depends upon their refractive index. On the basis of the refractive index, you'll find the cost of the gems increases or decreases. So what did you find? The refractive index that we have measured is a physical property. We find it is different along 3 different axes: X, Y, and Z axis. So most of the physical property that we measure for solids, crystalline solids are anisotropic in nature. That is, they are not similar. When you go for the amorphous substances, as they are being haphazardly arranged, they show a average physical property. So in all the 3 axes, X, Y, and Z axis, we find it is almost same. So this is called isotropic in nature. So it is one of the most important characteristics of amorphous substance and the crystalline substances. So today is the first day. So today I'll leave now. So we'll meet again on Thursday and Saturday. Okay. And as I told you that if you do not understand, please let us know. Clear? Bye then.
Thank you, sir.
Thank you.